Hello everyone. Hey, welcome. I see some people are joining, which is really nice. It's kind of a bit of an unexpected stream. Um, so yeah, I did a few changes. Let me know if you can still hear me. Yeah, or see for what it was. It's all good. I published a video of my yesterday recording to YouTube. So if you missed yesterday's stream, go watch on my YouTube and it's available fully there. Uh, Director's cut, no editing. And someone suggested to do like some changes with my microphone, like to reduce fan noise. If you watched already video or if you were here yesterday, let me know if it actually worked, like if there is less background noise or whatever, or if it's the same, at least if you can hear me, which is already good. We're going to start in a couple of minutes. Um, and basically, yeah, we will continue from yesterday. Hi everyone. I'm still experimenting with the settings. Uh, so yeah, if you can hear me, if audio is okay, please say something in the chat. Hello everyone and welcome who just joined. Thank you for confirming. Yes, good. Okay, I think we can start slowly. I'm going to share where we stopped last time. So yeah, if you missed it, little bit of context. I'm walking through this Haskell course. I did it 10 years ago when I was learning Haskell, and I did the course in Haskell, as it seems, but we are going to actually do it in C++. And yesterday, we kind of solved the first homework. We looked at some simple functions, how to do pipelines, and all of this stuff. And today we are going to solve the second homework, and it's about algebraic data types. So algebraic data types is this feature which is really nice in functional programming languages, and some modern languages trying to adopt this feature and bring it into themselves because it's really nice. It allows you to model. It's usually known as like sealed classes, or maybe like choice types, sometimes like discriminated unions, or very different names. This is like canonical name of algebraic data types, and there are multiple ways you do it. We will see how we can do it in C++. So obviously, I'm not going to read the explanation of Haskell. We are not learning Haskell. We are learning C++, but we are going to do homework in C++ for this task. We just make font a little bit bigger, and yeah, let's start. Second homework about algebraic data types. Something has gone terribly wrong. Yeah, we are doing functional programming in C++. I can relate. Files you will need. These files, file you should submit. Okay, there is beautiful picture of Bunny from Alice in Wonderland. A cute start. Anyway, log file parsing. We are really not sure what happened, but we did manage to recover the log file error.log. It seems to consist of a different log message in each line. Each line begins with a character indicating the type of log message it represents, I for informational messages, W for warnings, and E for errors. The error message lines then have an integer indicating the severity of the error, with 1 being the sort of error you might get around to caring about sometime next summer, and 100 being epic catastrophic failure. So basically, there is like some severity for errors, and the bigger the number, the more severe the error. By the way, I kind of like that there is like some story, and the professor put some effort into the course, like try to make it less boring and do this stuff. So yeah, it's really nice. All the types of log messages and have an integer timestamp followed by textual content that runs to the end of the line. Here is a snippet of the log file including informational message followed by two-level error messages. Okay, so here's like two examples. We have, this is basically one line of log, and it starts either with I or E or W, but there is no example of W. And there is integer like timestamp when it happened and the text of the log message. And if it's error, there is another number, which is the severity of error, and you basically want to work with that. It's all quite confusing, clearly. We need a program to sort through this mess. We've come up with some data types to capture the structure of this log format, and here it goes. Here it starts. So I'm going to explain, so obviously this is not tutorial on Haskell, this is like C++, and I'm going to explain this stuff, how to do it in C++. If there are like any questions, if you feel stuck, feel free to drop like message in the chat and ask. This is like interactive session. This is the beauty of a live stream. You know, when I go to some trainings or some in person or over Zoom, and there's like a teacher who actually answers questions, I'm trying to leverage this opportunity as much as I want. Like I'm already there. I'm sitting, I'm listening. Like why not ask questions? And I don't care if, like if it's obvious question, if it's stupid, if everyone else knows. It's what's important is for me is that I don't understand. I want to grow. I want to learn new things. So I can like even like ask stupid questions, like what are we doing and stuff. So anyway, if you're stuck, if you don't feel you get something, feel free to interrupt at any point. I don't know how much time we will spend on this, whether we will go through the entire homework. It's actually quite big, especially to do in C++, but at least we will start to kind of start slowly and ramp up gradually, and we'll see how it goes. So here it says that the message type is info or warning or error with integer. So in Haskell, this is how you read it. It's like pipe, it's like or, so it's a choice. So in real world, you kind of have things that you kind of have together. Let's say you have a date. I mean, as a year and a month and a day, like a time in the world. And this is like three components, like year, month, day. They kind of identify what is the date, what specific date you're talking about. So you need all of them together, like three components. But some things are choices. Let's say when you ordered something online and your order is can be in multiple statuses. Let's say it's not ordered yet, so you haven't done, or it's just pending payment, and you kind of specified the order what you want, but it's not paid, and then you paid, and now it's pending shipment, and after that it's like maybe shipped, and you see what the order and stuff. So like different states, and they have different parameters. So you see the real world kind of have and, like when you have multiple things at the same time, or choice, like or you have this or that or that. And here every line is a choice. It's either info or warning or error. But what's more important that if it's error, we have some additional payload, which is like integer. So this is like if it's error, it has some int associated. Hey, welcome, Shreyas. Yeah, not. We're actually going to touch monods briefly today, but I'm not going to explain it. I'm just going to use monods, but I'm not going to leverage them a lot. So we just starting with simple choice types. And if you are trying to, hey, hi, if you're trying to just model this in like with just records, just in your plain imperative language or object-oriented language, this is really painful because it's really simple. So you kind of want an enum, like simple enumeration, info, warning, or error, but there is this annoying part that you have integer with an error. And you can have like a structure where it has like enum, like this just info, warning, and error, and it always have this like error code inside, and and then it's mercy to the user to always check what's the status and whether error code is valid, but then it's not really easy to use. It becomes potentially error prone and all of this stuff. So here's the benefit of choice types, that you can do all of this stuff and you can model all of this stuff. So let's actually do this part in C++ straight away. here's my VS Code. I already created the second homework directory. It's it's the same project as from yesterday. Actually, all the sources are on GitHub. So what I'm writing here, in the stream, you will be able to see it later on the GitHub. Once we finish, I upload all the code, and you can already see the previous stuff. So yeah, I am using VS Code, and I'm using it with the Vim plugin just to make editing slightly easier, because like I don't need lots of IDE features. I sometimes mistype, so you can see random lines being deleted, random mods entering, and all of this stuff. Still something like I struggle even after like 10 years of using Vim and whatever. It's not really a big painful. Maybe I just need to practice more on typing and stuff. But yeah, we are going to type some code. So we had that, just remember that we had this kind of like type, which is, how was it called in message type? Okay. It's either info or warning or error within. So this is like in Haskell, it's really nice, really succinct, really easy to read. So C++ doesn't have native support for algebraic data types. So we cannot easily tell that it's like a choice between different types. But there is a library function, which is actually called like the utility like library called variant, and it allows us to do this. So what we're going to do to actually have this as a choice type in C++, we are going to implement every, like this case, they're called constructors in Haskell, but anyway, every this case as a separate struct. So info, warning, those are empty structs, so they don't have anything inside. But error, it actually has the code inside. So this is like our error inside code, and you can see these are like different types, but they are completely different types. Nothing binds them together. So this is where magic happens. We include this variant header, and we can say that our type, which is message type, it's a variant between these three choices. So it's either info or warning or error, and this is how you can read it. So this is like variant means it's an alternative. It's either this or that or the last thing, and it's based on templates. You can specify as many things as you want. I don't know if there is limits, maybe, but you don't want to have like hundreds alternatives anyway. And this is like with this using, we specify this is like type ls. So we are not going to use this, it's quite verbose, we are just going to name it. But basically this is our variant, and this is how we can introduce like a choice type. And if you do it like in C, if you want to do it in C, or if you want to know internally how it's implemented, is as a record. So it would have been something like that. So you would have a struct message type, you would have a tag, not necessarily integer, maybe like just one byte or just char, just to specify what constructor it is. And then you will have like a union, which has like info, warning, and error. So the union is this thing that it's not stored all of them kind of one after one. It stores them together, so it allocates the buffer to store the biggest one of them, and basically it allows you to reinterpret the bytes like directly as one of the types. And you have to be you have to keep this tag like really consistent with what's inside. So let's say tag 0 is info, tag 1 is warning, tag 3 is error, tag 2 is error, and then you kind of do all of this stuff. So this is how you would do it if you really want to do manually. It is possible, a little bit of boilerplate involved, but state variant kind of encapsulates this idea, provides lots of nice utilities. Yeah. enum and union is how you usually do. So yeah, you probably can do like enum, but fortunately we're not in C, we're in C++, so we can leverage some libraries provided to us, which is really nice. Okay, let's go back. So this was our message type, and there is like timestamp, which is just int, and we have a log message. This message type timestamp string and or it's unknown string, and there is some explanation what it means. Note that log message has two constructors, one to represent normally formatted log messages and one to represent anything else that does not fit the proper format. We provided you with the module log.hs containing the data type declarations, along with some other useful functions. Download log.hs and put it in the same folder where you intend to put your homework assignment. Please name your homework assignment, blah, 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 and this is how you import. So we are writing C++, not Haskell, and we cannot just import this file. We need to actually re-implement this stuff. Fortunately, not a big deal to re-implement all of these things, but we can see that it's not really hard to do this in C++. Let me just type this part as well. I'm going to delete this. It's just Haskell comment so I don't forget. You can do the same thing. We say timestamp is equals to int. By the way, just a nitpick, but actually you don't write timestamp with capital S. Like it's not two separate words. The timestamp is written like this. So and kind of the same for datetime. Just one word actually just nitpicks. Sometimes I see inconsistency. People think it's like two words, date and time, and it is semantically, but usually like you write timestamp with small, like it's one word, so just something for future. Anyway, and here in Haskell, you see that like two constructors of log message, like two cases, and one case is named exactly the same as the type. So in Haskell, this is okay because types and like constructors or cases or tags, they live in different namespaces. They don't overlap unless you use like dependent types, and then you kind of you are required to have different names. But in plain Haskell, this is fine. In C++, because we actually have to write separate type for every case individually, and we also need to name our entire type, we cannot reuse this kind of like the same constructor. So we are going to do something differently. I'm going to say that our entire type is log message, and this is just message. Anyway, not the best naming, is something I can came up quickly on the spot. So let's say we have message, and the message has message type, which is our actually choice types that we defined, and let's call it language type. I think it's not a keyword in C++, so we can use type. Yeah, so in Haskell, it's kind of like, you see, it's positional arguments, so you don't give them names. You can have a record and you have to give them name. Here, we actually always need to provide name, which is not actually a bad idea. Timestamp, and yes, this is like as a message itself. What MSG is. Big Java code. Let's also include string. We need unknown, which is just string, so not a big issue. Unknown string MSG, and now our type, which is just log message. It's again going to be a variant, so it's a choice between either message or unknown. We might need some utilities later to write, but for now this is kind of like how we modeled our domain. There are some questions in the chat. Do you use int in practice and not size types, or is it just for the sake of simplicity? Do you mean for the union type example previously, or in this tutorial? int. In most of the cases, like you do want to use ideally size, like to minimize if you really care about performance and squeezing the last bit. You want to choose the proper size. Yeah, I understand. Yeah, you int 8. Here we're just following the exercise. So we just using ints. So for this particular task, the domain is kind of rather simple and we can use ints. But in real type, I try to minimize usage. So I'm working on a game, like a video game in my free time. And you know, when you do a lot of things in a loop and you kind of want to use the smallest allocations possible, like smallest sizes and do performance. So there I'm trying to use specifically with the types. Yeah, int is bug and platform dependent. We are not writing platform dependent code in this example. It's just a case. Oh, someone did sys 194. Nice, nice. Um, yeah, it's a great course. Actually, what kind of made me finally understand Haskell and like work for me. It really matches how I think about programming and stuff. Yeah, we are doing it in C++. C++ didn't have lots of features in when I was learning C++, so I don't think it was quite easily possible to do in C++. I think you could, it just wasn't really convenient and you would not do it. Right now, I think it's not really too bad. And actually, there is like some C++ wins. There are like one thing that's actually really hard to do in Haskell, but easy in C++ due to this. So it's actually not too bad. Like spoiler alert, we will see something that actually much better in C++. Yeah, I mean, we're not going to do like class hierarchies. So normally, like how would you do it in old C++? You would actually maybe have like single virtual maybe interface message type, and you will like inherit from this message type, and you have different structs. I don't really like this approach. Is too heavyweight. So every time I do it, I feel like dirty. I feel like I'm doing something wrong. I just took away. There are a couple of problems that work really great in this way with like interfaces and stuff. But most of the time, you just want plain types, plain structs, and you just want to manipulate with structs. And you do OOP in occasional cases, but here we're just working with plain types. Anyway, um, let's go back. So we did all of the stuff, we imported model. Okay, first exercise. The first step is figuring out how to parse an individual message. Define a function parse message from string to log message, which parses an individual line from the log file. For example, parse message this should return log message, which has error with 2. So remember, like the error has priority code, and error, like the first number after error should be what's inside error. Then the timestamp 562, and the rest like is the message itself. And for example, if we see I, then we don't have like error code. We just have the timestamp and it goes here, and then the message itself, which is la la la. And if it's like in proper format, there's like it doesn't start with I, it doesn't start with E or with W, and there is like not proper number, then we say it's unknown. So actually, you can see that this is like first it's like it's not named here. It's like this functional programming pattern is not named here, but we actually we are using errors as values. So you see this type log message, it has this case unknown, which means that like this parsing, it never throws exception. Like if you give it empty string, if you give it invalid string, it just goes into unknown, and it never throws exception. It uses actual values as errors. Yeah, now that I think about why it's called errors as values, it's actually values as errors. Anyway, it doesn't matter. Naming is always confusing. So yeah, and we always can return unknown. So in any case, something with parsing fails, and we're going to do this. And okay, once we can parse one log message, we can parse a whole log file, define function parse, which takes entire log file at once and throws its contents of this log message. So this like pure function in Haskell, it's not actually supposed to read a file. So like doing IO in Haskell a bit more difficult than in other languages. It just gives the entire file content like as lines separated, and you split it by lines, and then you parse and you get like a list of log messages. So to test your function, you can use this, and don't reinvent the wheel. That's all last week. Use prelude functions to make solutions. So there are not a lot of functions not a lot of functions like this in C++ library, but we are going to write them. We are definitely going to do some ranges and some pipeline programming. Oh, hey, hello. New people are joining. This is always nice. So yeah, we are going to use pipelines from the last part. So if you didn't get something yesterday about pipelines or how we use ranges and views in C++, this is your chance. You can ask more questions. You will see it used more in practice. And this is like really powerful technique to do this stuff. But yeah, we're going to write a function with parsing one message, and then we're going to parse like then basically the entire line with lots of messages. So this feels a little bit like advent of code. if you ever solved it, and if you're going to solve it, it's usually all about parsing. You have this like some data with some weird format. It's not the worst format. It would have been really worse, and you need to parse it. And because we use like choice types, we need to model all of this stuff. So let me actually copy these examples so I don't forget what's happening here. And yeah, let's jump to the code and actually implement this parser function. What year? So the question, what year this notes from? So yeah, there are actually two courses. So the one I'm doing is from 2013. Actually, let me just show you. If you search for, so there are like two courses: there's spring 2013 and there is fall 2016. So different people did this course. So in 2016 was done by Joachim. He's a really famous and great Haskell developer, and it's a bit different. I think there are like maybe like different explanations. It may be more oriented, I think, on graphical design or something like that. So yeah, you use Code World, and does it still work? I wonder. Too bad it doesn't work. Oh no, it works. Yeah, so they kind of how do I close it? It's oriented on more visual stuff. So you already have some code and you can draw it. Yeah, unfortunately, some things don't work anymore, so it's completely different. I haven't done this course from 2016, so that's why I'm not going it on. It's more like a nostalgia, traveling through the road of nostalgia of this course that I did, and walking you all with me alongside. But yeah, you can actually try both, and whatever works best for you. This one actually works for me. I don't remember all of the tasks. I remember I struggled with them a lot when I was learning Haskell. And yeah, hopefully I'm not going to struggle with C++, but we'll see. Oh, hey, hello. People are joining. That's always nice. Anyway, let's do this parsing. So already 30 minutes past stream, and I already feel from this like task description, it's going to be a bit annoying. We might actually finish after implementing this function, not because it's like particularly difficult, but because I'm going to explain and unwrap a lot of these concepts, and we can take it chill, so we don't need to rush or whatever. But anyway, yeah. We want to write a function, parse message, which takes a string. Let's do it like this. Whatever. And it returns a log message. So log message is our state variant. And you can see, sorry, not log variant, log message. And you can see that this function, like it's not going to throw any exceptions. If any input is invalid, it's going to handle it properly and do all of this stuff. So let's do minimal implementation. Let's do proper TDD like we did last time. And I'm going to return unknown, some empty string. Let's actually check that our code still compiles. We haven't written. Yeah, it just complains about unused variables, but overall it compiles, which is great. So we're returning log message, but you see I'm actually returning unknown. So how it works, even though it's like it's a variant, those independent types, and they're implicitly converted to this variant. So you don't need to convert it to variant or whatever. It automatically recognizes, oh, log message has unknown, and like I'm returning unknown, so it can be easily casted to this, like no problem. And because unknown is a like simple aggregate type, it has just one field. I don't need to write any constructors. I can just initialize field with one just empty string for now. And we actually want to write some test cases. So let's actually write these test cases, because this is what we're actually going to expect. And I'm not using any like testing frameworks. I'm just using good old assert, and we're just going to do this as assert. So let's do this, best, and this is our parse message. It takes this string, and we expect that it should be equal to, okay, so it should be equal to log message, which is constructor, but we rename constructor to just message. So our constructor will be message. It will have several fields. So the first one is message type, which is error. So we say it's error from 2. This is like status code. Then there is like timestamp, 562, and there is like string help, and this is what we're going to do. No operator matches this. Okay, so the first thing is that we need to compare values of our type. So this is like a log message, it's just variant, and out of the box, like C++ doesn't provide you comparison operator out of the box. It doesn't know, even though it's kind of obvious how you want to compare for equality, you just check field by field, so it could do this for you, but it doesn't do it explicitly. It's still some code that needs to be done. And we need to actually write how to compare our types. So variant is smart, actually. If you can compare all of these types, then it automatically can compare variants. So for variants, we don't need to do anything, but we need to tell how to compare messages with each other, how to compare unknowns. And because message has message type, we also need to do this for structs, info, warning, and error. We need to do all of this stuff. So like if you were old days, you actually had to go and write all of this boilerplate, like you had to write all of these comparison functions. But actually, since C++, I don't know, 17 or 20, there is this like spaceship operator, and it allows you to generate comparison for all your types automatically. So what you do, you write auto operator, well, less equal bigger, which is called spaceship, and this operator, it takes const ref to your other object. It's a const operator, and you say that it's default. So this is how you can generate this comparison operator for your own types. Okay, it complains about this, maybe let me see what's wrong here. There's always a huge error. So this is about like this, we know. Expert, const locator. Yeah, maybe error is actually different, but as far as I remember, this is how you do it. Let's do it for every type, and let's make I'm using the latest standard, so it should be good. I know what's happening, but we are definitely not going to write all of these operators manually. Last resort, we are going to ask ChatGPT to help us. Next time we don't need to do this. Not explaining this particular part, just what you need to know that it generates like comparison, equal operators, this equality and all of this stuff. So basically, it's how you can generate a lot of things. This is really weird. Maybe write it like this. Message. Okay, it says so here. It actually, I think what's wrong here is that it's trying, even though here implicit cast worked, here it's somehow not able to implicitly cast this message to log message. Yeah, the C++ errors. Usually, like there is like this rule of thumb. The bigger the C++ error, the stupider your mistake. So because it's like really huge, it means we did something really stupid and really something small. I think we need to convert this message to variant. Oh my god. Let me see. Damn. Okay. Will this work? And not a fan of implicit type conversions in C++. Yeah. Let's do really easy stuff. Let me quickly check. So I wonder if there's like maybe some, okay, there are some constructors. So we don't want to use like implicit conversion. We want to do this thing. Yeah, let's try. Who knows where it leads us. We are learning here. It's fine. We are in no rush. So we do message, and apparently we do log message. Oh, God. Message. And well, now it's worked. Yeah, we just needed to convert it to log message properly. So like we invoking constructor of our variant, which is log message, and then we are going to do this message. A little bit of conversion just to make operator equality happy. ID is still not happy about this operator. I will have to look at this later to figure out what's wrong, but at least the code compiles and we see that our assertion failed with this message. Well, obviously because we return unknown, but at least it did something. Okay, let's implement all test cases. Be a little bit of boilerplate, but at least we will have kind of like a minimal test suite we can run against and verify that we didn't do anything stupid. So here, what we have information. So instead of error, we have info, and we kind of still need to at least initialize it somehow with empty brackets because it doesn't have nothing. So the timestamp is 29 and the text is la la la. And we are going to do this again for this string. And here we actually return not message, we return unknown. And inside unknowns will be exactly the same string. Check it still compiles, but tests are not passing. Okay, now we can actually implement the function. Can the type coercion be tucked into the equality implementation? I'm not sure. So we're using auto-generated implementation of equality, and it specifically tells this type. So technically speaking, this type is not the same as this. So not technically, but really they are different types. Here, when we return, they kind of can be implicitly cast because we're not doing any other operation. We're explicitly doing actually the conversion operation. If it was return type boolean and it was integer, it would cast boolean to integer. So this works. When you do all of these other functions, when you call like operator equality and they expect some particular things, then it becomes harder because now you kind of want to do implicit conversion plus something else. There are some rules in C++ how you can, or how the stack overloading works in conversion, but for simplicity we can do this. What you can do, you can kind of write helper functions like make message, make unknown, that just take these arguments and create you. So you don't do this duplication inequality. You can just have not smart constructors, but in some sense constructors, and then you can do all of this stuff. Yeah. Anyway, I hope you're still with me. We have some tests. We did some data types, but we actually haven't written any real code that solves the problem yet. Let's actually do this. So how are we going to do this? You can think about like for yourself, how would you solve this problem? Like probably you would try to match on the first character of the string. You would see if it's E or I or W, but then you would need to check if then either it's like it's followed by space, and if it's E, there like should be two numbers after that, and if it's I only one number, and then we need to skip space and then go to this string. So if you think about all of these cases in string handling, it becomes really tedious. So we are not going to do all of that stuff. We are going to do maybe not the most efficient and performant implementation, but it should be more or less easy to understand, easy to maintain and extend if another case happens. So the first thing we are going to do is we are going to split this line into words. Specifically, we are going to split it by spaces. And we're going to look at the individual elements of the resulting split thing one by one. So to do this, we're actually going back to the previous slide. We're going back to ranges, and there are some nice functions available there. So let's go, let's enable ranges. So the first wonderful function available there is actually split. And we are going to say that let's do this, we will clarify it later, that our words, we can call it words, is our string, and it's split, use split, is it split or split by? 1 second, guys. Use split, it's split. Okay, it's actually split. Good. And we can pass it delimited to the string, so we're going to split by space, and this is what we're going to do. So once we split by spaces, oh, hello, new people are joining. This is really nice. Yeah, you didn't miss, if you just joined, you didn't miss much, because we actually just started writing the real code that solves the problem. We defined our types to model our domain, like some type messages, and now we are going to parse these strings into this some types. We started programming about 40 minutes ago, so we spent a lot of time on all of this preamble, but hopefully at least it was a little bit educational. It's actually not here, just is it? No, it's used. Okay. ID doesn't want to cooperate with me. I will figure out later. I mean, at what age? I would say, I'll be mysterious and I say half my life ago. So I'm actually really half life. That's half of my life I've been programming. And big part of this we are spending on this problem, so bear with me. So anyway, we take a string, we split it into words, and now we have a kind of pipeline, like a lazy generated pipeline that gives us the words. But every single word is actually not a string, it's a range. If you remember views, I about like really this lazy conversion, all of this stuff. So we want to transform every single range into actual string. We actually want to work with a vector of strings, if it makes sense. So we are going to use still use transform, and still use transform is kind of like functional map. I give it a function and it converts stuff to it. So we don't do any captures. Say const auto whatever. So like range, and here we return string from this range. Do we do range in, range m? So this should actually convert this. So we get string, we split into stream of ranges, and we get this every range into strings. So now we have a stream of strings, and now what we actually want to convert them to vector. We want to combine and assemble all of this stuff. So we can do stint ranges too, and there is this nice like feature. It's available in C++23, where it basically allows you to aggregate all of this stuff. And here we actually words, we want to have vector of strings. This is our words. And let's add a couple of imports. We need vector for this stuff. And let's try to print it to see if it actually works for words and words. Word. Let's actually split them by this line, so we actually know when the word ends and when it starts. Yeah, the idea complains we might need to fix a few compile errors. Oh, not compile it, not you. Expected primary expression before. Okay. What? Oh. Starter missing to data argument before token. It is really weird. It's not a member of std ranges. Okay, maybe it's actually an algorithm. Bring this to C++. It's in ranges. Ah, too bad. It's in C++23, but maybe it's not available in my old compiler. I'm using, like as you see here, GCC 1.3, and it doesn't have proper support of C++23. Maybe it's actually I will update it at some point of time. Anyway, we won't have any goodies for now. We can always do this. We will have words pipe. Or actually, let's do this words. Words. Push back. Move. Want to reuse it as much as possible. We're not going to use this pipeline, and now we can do this stuff. This works. Little bit of missing punctuation. Okay. It's nice to have warnings that complain about unused variables, so you can actually see what went wrong. Okay, now we see that it parsed our words as separate strings E2, 562, help, help. So it worked correctly, which is really nice. Am I using Clang? No, I'm actually using GCC. So it's like G++ is GCC, I think. Should do C++ -v tells you like the GCC version of on Ubuntu and stuff like that. So probably need to update it. I didn't notice any like big difference. There is like a new version of GCC which is 1.4, and it has this stuff and a lot of other stuff from C++23. This version supports only like limited subset of C++23. Maybe I actually need to update my compiler. Generate compiler commands and use Clang DVS code extension. Smart. Yeah, I need to figure out the ID properly. I mean, we can always use Godbolt. I can just ditch VS Code and go to Godbolt, do it like really old school bare bones style. But anyway, so we split into words. Let's actually enumerate words. Something for future ourselves, so we don't forget. So yeah, basically what I told with the ranges 2, this is what it does. It will automatically move all of the stuff into the vector, and you don't need to write this for loop. But anyway, we can figure out later. So at least this works. Let's comment stuff. So the next thing, now that we have actually list of words, we don't need to care like whether like space between after that or not. We just need to check whether our element is correct. So first of all, we need to check the first element of our vector words. Basically, if word 0 equals something. So already you kind of see a problem, because if it were an empty string, then like you can kind of get out of bounds exception, and then okay, we check the previous, but then we need to check the first and the second index and all the stuff, and every time you need to check whether the element of array, so whether the element of vector is inbounds or outbounds. So we actually can write a helper function, which will be like a lambda function. We call it get, and it will be a function that takes index and it returns an element of our vector words by index. This is like simple lambda, but not just this, it will actually do the bounds check. So first of all, to access words, we need to pass it. We will pass it by reference, so we don't need to copy the full vector. And we are going to do some checks. So first of all, if I is less than words size, then we're actually going to return words I. Otherwise, so like when I mentioned something about monads in the beginning, this is how we can do it in functional style. So we need to return something when the element is not present, and later we can gracefully handle errors, so that like we can easily fall back to all of the cases when the input is invalid. So a nice functional pattern here is yes, exactly, optional. This thing are going to return optional of element of our vector. So our vector has strings, and this will be optional of string. And we can specify in the type signature, this is like in Lambda, how you can clarify what the return type of your Lambda. And if it's not present, we will return stdnolopt. Stdnolopt is a value for this like optional, which means it's not there. And again, to use optional, we need to include it. This is another module. It's really like interesting thing. So this will be like kind of helper function, and you use it like this. So you just get, let's say, by 3, and it returns you optional of whether there is like element of this or not. Well, we don't use it now, but can actually, let's double check that it so far compiles. Okay, it says sign compare, long unsigned int. Okay. I think this is what they want, because long unsigned int size t. Okay. Okay, now it shut up. So how are we going to use it? Actually, so okay, it's nice to have this like wonderful local function, helper, and all of this stuff. Let me actually go to the browser again, and going to search for optional in C++, going to reference, and there is like, it's actually surprisingly like small utility modules. There's like not a lot of function if you compare to others, but they're, I would say, quite terse and really relevant. And specifically, we want to use these functions, which are value, value or, and then transform or else. So value returns you what's inside optional. But so let's say if you have optional of string, it just returns you optional inside. But it is unsafe, because if there is nothing inside optional, it will actually throw this exception. As you can see, bad optional access. So this is not unsafe, this is not safe, and it's not encouraged to use. So the safest thing is value or, and value or allows you to kind of return thing, like if optional is empty, like if there is nothing, it will return what's inside here. And we actually can already leverage value or. So we will actually, let's say, we will return get by 0, and if there is no element by 0, let's say if there is an empty string, we can say value or, and value or, and we are going to actually return unknown of our input string, which is string. Let's do align. Let's actually do this. Remove complaints to log message. Yeah, so it here it complains because actually we return string, and the thing that we get here, it should actually return what should we return. So for now we didn't do much, but we will kind of build this pipeline over time and figure out, but it's kind of like we will have lots of actions, and if they fail, we will return our unknown result, and this is like kind of our fallback, which is really nice. Let's go back to optional API. Oh, hey, CodeCat. Yeah, it's nice to see more people joining, or some people leaving, but anyway, you will be able to watch the full VOD later on YouTube. We are almost there, we're almost done with parsing, so bear with me a little bit more. There was like type safety police coming for me, but we will continue nevertheless. Anyway, the function that we really want to use, which is called and then, and this is like powerful function. It's what like about monads and all of this stuff. Like there are some small things, but there is this example, and it kind of explains what you do, and we kind of want to build similar pipeline. So you start with some optional. So this is like here we have an example vector of optionals, and you see it's optional of strings, so strings converts it to optionals, and then they do like if it's not optional, we return some simple optionals, then we do and then we transform and do value or and blah blah blah. We kind of build this pipeline and automatically handles all of this stuff. Okay, hi, more people are joining. It's all good. And then is this function that kind of and then is this method that takes a function, and this function has specific shape. It should take what's inside optional. So if our optional is string, it takes string, and it function should return optional of something else. So here it says function to int, which takes string view. String view is not only view of string. It's like, so you don't need to pass like entire string. Anyway, maybe separately we can talk about it. And it returns optional of int. So this function parses string view and returns int. Actually, we are going to parse integers as well. So let's just copy this function. It's going to be really useful. We accidentally found something that we can use. But generally, the idea is that we are going to do this. We're going to do and then. We're going to do this parsing. We're going to do this with get and all of this stuff. Now, let's actually see how to build this functional pipeline. First, let me copy this doing function. It takes from chars. Chars comes from char-conf. It's written in a little bit, I would say, modern C++ way. Let's make it less alien to people. So actually what it means is that it kind of does this function from chars. It returns this from chars result, and from chars result, it's this like record of two fields. It has some error code inside, and if this error code is, well, if it's error, then we return R. So it will store the result in this R variable. So you pass mutable reference, it doesn't return you integer or whatever, it will store result here. Otherwise, it will return null opt. So this will be our function to parse string view to optional. So as I said, string view, it's kind of like not only view of string. You can pass string, it will be automatically converted to string view. So it should be good and should work for us. So anyway, what we do here, we get an element, the first element of the vector. If it's immediately becomes null opt, so there's like empty string, no vectors, no words, we will fall back to value or, and we will return unknown string. So nothing will happen. We automatically handle this edge case where there's like empty string. Otherwise, if it's like not empty, we do and then, and we need to pass a callback here, like a function, what to do, and it will take string. You can actually, I think, to do and because it's like index 0, this is what we expect for message type. Is it not message type? It's called message type. It's called MSG type string close lambda, and this will be our lambda in Z. And here we can return something. We need to return optional of something, but it can convert this optional. And I think I don't have and then as well. Oh no, it doesn't complain about and then. Good stuff. I mean, it complains in the IDE, but not in the compiler. Yeah, definitely figure out this stuff. IDE is not helpful. So anyway, we get the element at index 0. This should be a string representing our status type. Our message, let's make it friendly to alignment. And what we want here, we actually want to check what is the message type. So if message type equals, let's start with simple ones, info, or if it equals warning, or if it equals error, or something else. So this is kind of like one thing that in C++ there is no proper pattern matching, and there is like switch statement, but it doesn't work on strings. There are like some different interesting hacks people do to make it work on strings. They're not really worth it. So it's a bit unfortunate, but if you actually want to check that different possible cases, we have to do like message type string. Why is words a vector string and not vector string view? Good question. I think it could be string view. I don't think nothing prevents it, just for simplicity, so I don't need to think about lifetimes and using all of this stuff. I'm started using string views only recently, and I'm not really comfortable with them. So for the sake of learning exercise, just string should be good enough. But I agree, in real world, you want to use like string views and be efficient, and it will work really nice. Ideally, you don't want to allocate strings and all of this stuff. And yeah, we are doing all of this stuff, and there will be some code duplication, but we will see how we can remove code duplication. So if nothing of this, so our status is not information or W or E, we actually just return null opt, because remember, and then it actually should return us optional, and we are going to store something in this optional. So let's actually for the sake of code simplicity, again, because we're not using expression-oriented language, let's actually do this stuff. So optional of log message, this will be our result, and what we are going to return our lambda. And here, I think by default it's null opt, but just to be safe, we can say that result is null opt. So if it doesn't match any of these cases, we just say that result is null opt. And then all of this stuff. I think now it should actually compile. Shouldn't complain all of this stuff. Yep, it compiles. Tests are still failing because we haven't written anything else. But at least we return proper result, and because this and then returns log message that we expect if it's not null opt. And if any of these cases, branches, or here it returns null opt, it immediately just fallbacks to unknown string, which is really nice. Okay, so let's handle the first case, which is I. So if it's I, so it's information, it means that the second element should actually be a number. So what we are going to do, we are going to say that let's get element by index 1, and we actually want it to parse as a number. And remember, get returns optional. So here we're using and then again. So I want to use this function to int, and it will parse number as a string. Where was it? Yeah, or it will be optional. So the result of optional here is now integer, and this entire expression has type of optional of integers. And now we want to convert this optional of integers to something like really meaningful. So if we actually here, let's say, let me do transform. There is this model, this like transform, which is also map. So if we are inside here, it means we passed this check. So the first element exists. Good, we pass this check. It's actually info, so we passed, it's a valid message type, which is good. We are getting the first element. Again, we pass this check, first element exists. We pass this check, it's integer, so we pass as an integer. And now it means we actually have everything to return a proper log message. So now we say that, okay, this is like int of this timestamp. So inside this optional int, and we can actually return a proper log message, which is let's do proper cast. So because it's information, we return message, and we pass this check, which is I, so it will be info. We have timestamp, and the rest of the string, which is actually all the elements of the vector starting from the second element. So we can somehow calculate the number of characters we want to skip from string, but like numbers timestamps can have different numbers. It's not really easy. So what we do instead, and this is what I said when I meant the implementation will be not really efficient, we are actually going to unwords this vector. So we are going to combine it back to the original thing, but we are going to skip a few elements. So let's actually write a helper function for this. We're going to write a helper function which returns a string. It calls unwords. It takes a vector of string. It's called words. And it takes reference to this vector, and it takes don't really like this, but let's say it takes an integer things to drop. So how many elements from the vector we are going to drop, and we are going to kind of skip first elements of this vector and combine the stuff. So this actually can be done in a functional way too. Again, if we had some helpful utilities from GCC 14 and some news, it will be really like one-liner to write this stuff. But unfortunately, we are going to write it in a little bit hardcore way. And let's say our words pipe is words. We are going to drop elements from the beginning of this vector, and there is actually functions called drop just for this. Just pass it to drop integer. So what it will do, it will skip first to drop elements of the vector, and it will give us the view of all of these vectors. And now what we want to join all of the remaining elements of the vector with a space. And again, there is a function called join with, and we just pass it single space. And kind of this is what we do. We skip first elements of the vector and we join them with space. But now we need to return string. I would really love to have like use standard function, but can I, by the way, maybe use full? I think I can. That won't be really efficient. Anyway. Yeah, we are going to write some not the best efficient code, but it should do the trick. It's characters now. Maybe actually I can do this. One second. I think this should work. So we created a pipe, but actually like we joined it with characters, and now it's actually a pipeline of it's a stream of characters in some sense, if it makes sense, and we're just going to create string from this iterator. Hope it works. Surprisingly it works. It doesn't compile. Get is not captured. Okay, interesting. yeah, get is kind of our local function. We cannot easily reuse it. We need to capture it by reference, which is really interesting. Then, or we can just capture everything, but usually it's generally best practice to capture only what you need. Anyway, now we can actually return log message of like unwords, our vector words, and I think we need to capture words here as well. And I think it's going to propagate this bit annoying part that you have to do all of these things. And we're going to skip first two elements. So this is like what we did. We get elements, and this returned our log message, and we actually want to return this stuff. So our result will be this. Maybe we can align it with. Basically, this is what we do. We get one integer, we then convert it to integer. So we get element of by index, then we convert, and if all is good, then we just construct our message from info. It's actually now double check that it compiles. I might miss. Yeah, it compiles. It runs. That's not passing because the first case is error. But if we actually switch test cases, so this test case should actually pass now. Yeah, it fails on the error test case, meaning that this assert is now passing. So we actually did this case. We support it, which is really nice. So because warning is exactly the same as info, we can actually copy paste this entire code and it will work. The only thing we need to change is replace info with warning here. And here you see this is like almost exactly the copy paste of itself. So it almost feels like exactly the same code. Why can't we extract it into a separate function that just accepts this argument and does all of these things? This actually sounds like a good idea, but remember, if you do dry too early, hey new people, thanks you for joining. We are almost finished with this function, and I think with the stream as well, because this function took a lot of time to do and explain what's going on. But yeah, I've been talking about this like almost exactly the same code as here, and like if you don't repeat yourself, dry too soon, if you reach out to it, then you can come up with something not really great, and it will be maybe not really easy to use. So because we haven't finished the error case yet, actually it's good to finish it even with duplication, and then you will kind of have a full picture of this stuff, and you'll be able to notice how to do patterns here. So we will still going to copy paste this thing. So the challenge with error, why error is more difficult, is because there are like two numbers. So inside, if we got first number, this is actually the error code, and we need to get another number after that, which is like not error code, which is actually timestamp. So this will become more elaborate. So here we get this lambda, we get const string code string. We will do this, and here we actually do int from code string, and if this to int actually succeeded, then we need to do and then again, and this and then will kind of take int code, and after like parsing succeeded of this thing, we now want to get the second element, which is actually our timestamp. So now we get by second element, we do then int, and then we do this stuff. So you see it became more nested. We now need to figure out that, like, what do we actually return. So we return this thing, we close this lambda, and we return this, and we need to pass like all this reference, which is a bit annoying. There is maybe some specification to do for this stuff. I don't see yet. But generally, like in functional programming languages, there is a thing called like do notation, like in Haskell, or in a camel there is let star, and it allows you to avoid this callback hell. You can write proper linear code. I think you maybe with some compiler torture you can do this in C++ as well. So I feel like it definitely could be written much nicer. But the idea is that it's kind of like we do this pipeline nested like style of things. So with every time like and then fails or like whatever fails, we kind of fall back to this null opt case, and the entire thing collapses at the first and then failed, and we get this like null opt, and eventually it's like value or. So it's really, in some sense, it's really lazy, so it doesn't do more work than necessary. If you try to write this function with without like optionals and with simple things, it won't really be much better. I mean, I don't like this part with words and get. I think we can refactor the stuff. It's definitely maybe something to try when we look into this, but at least this should work. So if we do now compilation and try to run these tests, we did miss few things. Okay, now after this result, we need to close bracket. That's a valid complaint. Okay, and obviously because now it's like it's a warning. If we parse an error, we actually need to return code here, and we're going to we see code here as an argument, but in this lambda we don't see it, so we need to pass it in this lambda. So our session failed, and now we need to figure out. Okay, I know why it failed, because we skip like not 2 words but 3 words. We skip the error status code, we skip the error priority, and we skip the what's the timestamp. Okay, now the tests are passed. No complaints, no sick fault anymore. So this ugly S does the job, not in the best way. That's the functional way. And if you just do it like in a quick, dirty style, you can see there are lots of things. And if I were like reviewing this code, I would not accept it personally, because there are a few things to actually do and refactor. So we will spend some time trying to refactor all of these things, because now we actually have complete implementation, and during refactoring we don't want to just reduce the code, we actually want to like make it better, make it understandable and readable. So let's pause for a moment here. Let me know if you have questions, if you want me to elaborate on something here, but I'll answer some questions in the chat meanwhile. Can you recommend book or course for learning programming? I mean, I can recommend watching my stream. You will definitely learn some programming. Generally, if you start programming from scratch, I don't know. I haven't been learning programming from scratch for a while. I don't know what's the actual modern resources. And I think there are plenty of courses. So I know there's like Computer Science 50, this like course online you can find. It gives you a pretty foundational introduction to programming. It gives you like programming in Python and C, and like a lot of high level overview. So it's a good intro. There's like several hours of lectures on YouTube. It's like free. You can find it online and watch it. It will be good enough. I've heard lots of positive things about it. There are other things, but basically you can just start from something try to build program, try to write really simple problems and grasp concepts gradually. It takes time, so it takes time to actually understand it. I heard that some ungodliness was being crafted live on stream. I came to see for myself. Good lord. Yeah, yeah. Not my proudest code. Just like, when you almost like vibe coded, but in an old sense of vibe. We just followed with functional programming vibes, do the stuff just to get the stuff done and compile. And it definitely needs to be refactored in some sense. Some functional programming features make it really easy. So for example, in C++, you have to specify all captures in lambdas explicitly. In functional programming languages, captures are implicit. So we could do this. We could just write like ampersands everywhere and it will work. It's just not a great practice. Ideally, you just want minimal lambdas, but generally speaking, this like one thing. And because like we don't have in C++, you need to write a return. You don't have expression-oriented languages. You cannot just return things. You have to do like return. Lambdas be more explicit. So there are these things. Yeah, trust in the process. I mean, at least it worked. Yeah, it can be really weird. I try to like walk through every step, what's going on here, what's happening. Um, um, Maybe at least every step makes sense. The result is not in the best shape, but at least it was. So what the great thing here is that now we have a test suite. I mean, not the best. It is something, but at least when you refactor, you will have more confidence that things actually work as you expect. And maybe optional is redundant. Actually, I don't think it's bad because we have several levels of indirection. So we have this constructor of which is actually log message. So we convert it to message, and then this log message it's like this variant instead of optional. So then this implicitly needs to be converted to optional. So if we have too much implicitness, compiler error messages could be really great. Hey people. Yeah, make it work, make it right, make it fast something. So some string views were mentioned in the past. So string views is one thing you want to do to make it fast. So the idea of functional style that it should be extendable. Let's say if you want to add another case, like we say with critical error or whatever, you can kind of just need to add another case here, else pipeline, and then you have like building blocks of like getting elements of vector element by element and then parsing to integer. So you have built-in blocks. Maybe you just need to introduce several helper functions to make it easier. And let's try to refactor. Feel free to stick around to see how we struggle with this. Let me actually commit the stuff. We did a lot of these things, so I'm going to commit the initial integration to. We haven't even parsed all messages, just one, but I think it's so this. Okay, you can have a look at the code if you really want. You can kind of make your take on the refactoring. But first thing to notice is that I'm not really concerned about this part. This is almost optimal in this helper function. Is that here we do like parsing to integers. So like we get element by index, and then we kind of immediately parse it. So the first thing we can do is we can kind of combine this get and then gotta go. Should really ditch Microsoft extension get C1. Okay, thanks for suggestions, Ray. See you. Yeah, I will stream next weekend, so hopefully I will have plenty of time to figure out how it works. I mean, at least I have a like stress test case for the code base. Like it should work on this simple project. So I can verify that IDE works and we will have less errors, not this annoying red lines. And yeah, definitely something to figure out how it works. Kind of a bit unexpected, but anyway, good stuff. Anyway, where we been? So we are let's try to think about refactor. So what we do actually when we do get, we also want to immediately parse it as an integer. So why not just extract this particular case and just return this thing? So like we get by index and then we return parse an integer. We can call it like function get integer. And the nice thing about functional programming and why I generally like it, why I generally advocate for it, is that it's kind of really composable. So you can get this like small parts and you can actually extract them. So let's see how it works. We can actually write function get int. In fact, we're just going to copy this part. So it takes get. I have to maybe simplify a few things, and it returns us optional of it. Oh, hey, hello. We didn't join too late in the evening. We're just trying to refactor this ugly piece of code. And people say not to call code ugly, it's kind of deprecating, but we can call things for whatever it is, and it's my code. Yeah, we can call it ugly, so we can try to do this stuff. So anyway, we are going to get int, and here we can actually do like proper composition. We can do get by I, and because get already captured words, we don't need to capture it here, which is nice. And then, which actually reads like literal English, is again another feature of functional programming. You can read it by English. Like what is get int? You get index and then you convert it to int. Done. That's all. So that's basically our get int function. We just extracted it and we can do things. So here, instead of doing get by one and then to int, we can just say get int one, and we could capture get int by reference. And here you'll see that it will work, and this get int returns is optional, and transform works this way. Like if there is null inside, then it won't do anything. So because there is null inside, there's nothing to transform. It will just return you the null, and nothing will actually happen. So this lambda will not locate anything, will not do it. It kind of tells you what to do if there is inside. And basically we do this thing. So again, here instead of doing get it and then, we do just get int by one, and here same. So we don't really need code string. I think I was a little bit premature here in terms of, not premature, maybe a little bit extra careful with what we need. But I think what we can actually do is that we can do this get int one. And then, so here we get our code, and okay, reduce one lambda, and the same here. We do get int two, transform number transform. Same. Yeah, I think it doesn't like this stuff. Expects the primary expression before getting one. Close the line. Okay. This is weird. Right company about transform. Okay, just this code being this code. Yeah, so you see we a little bit simplified. Now it's not as bad. So now you can see that there is kind of like pattern. We get by integer number, we capture codes, and we get another integer, and then this like nested pipeline. Yeah, thank you, Legend. So you see what I did with refactoring. I didn't try to do refactoring like top to bottom. So I didn't extract this huge function, just extracting relevant parameters and trying to do. What I did is that I noticed like local functions, which we like have small functions, and then extracting those parts. And this is what I learned uh, from like functional programming, is that this idea motivation that you really have this small functions, and you kind of compose them into bigger and bigger things, and it's much easier to actually compose smaller functions than try to do like this big monster and this like composition and trying to like combine together, like try to fit everything in this like huge black box with lots of like levers and the buttons and whatever things. And because we reduce the code, like you extract the small functions, this code becomes smaller and smaller. This is how we actually do refactoring in functional style. And as it becomes smaller, it's actually much easier to see why it's similar. So I mean, even 2 lines here, now we notice, okay, what we actually do a lot, we do get int and transform, and after that we create a log message with all of the things. And here we do get in, but then here and then get in and transform. So there's like plenty of opportunities to improve this further. Again, we can write this like helper function, and this is like which is really nice about functional programming. And yeah, factorization time, exactly. We are trying to factor out all of these small things. So first of all, let's create helper function to create all of this like log messages. So you see we repeat all of this stuff, and like this constructor is log message, all of these things. So you see what we really want. So like common parts, we need to pass the type, what is the message type, we need to pass timestamp, and we need to pass a string. So let's actually go back to our message type, and let's actually create let's go here, let's create a function. It's called make a message. It takes arguments of the message constructor, and it just returns this log message of message. And we need is a message type tag. We pass it by value because it's really small. It's like usually what we do in C++. When the value is really small, we pass it by value type, and well, string is big, so we pass it by reference. I think we can pass it by value and move it. It's actually yeah, because we're going to construct it. I think it will avoid copy because we pass by value and construct in place. Should be good enough. And here we return. Here, notice we don't need to like convert to log message because we already have these things. And like it will automatically implicitly convert message to log message because it's now it's part of this variant. And it's a really simple function. So can even do, because we passed by value the string, we can avoid the extra copy and move it inside. Just like an extra thing. We probably want to like optimize it more, how we use move and all of this stuff, but it's like one of few things you can do just for free, just to avoid some mistakes. And even with this simple function, like make message, you see it's like really stupid. We just take arguments and we just construct all of these things. We will see how this will be simplified. So instead of returning this thing, I'll comment it. We actually can say make message of info timestamp and this thing. And if you compare, you can see there's slightly less noise. So there's like no like message conversion. We don't need to mention this constructor. So we can do the same here, but instead of we do warning, and here we do error with code, and words read. See, it still works. Always good to check because you never know how refactoring goes. And kind of like we're doing this confident refactoring. So we did, it became a little bit nicer, smaller, But you notice that now it's kind of, some sense, easier to see patterns. So here, like this make message kind of does um, the same thing. So you pass it like warning, timestamp, and onwards. It's tempting to write a helper function that kind of takes just warning, maybe somehow captures timestamp, and it maybe takes onwards, so you don't need to pass onwards. But this is where it gets tricky. So it's something, again, from my experience, from my gut feeling. It feels like that this part particular might change, might evolve. So this is like kind of good enough. Maybe if we will see it in the future, it makes sense. But having an extra function that takes this number and just doesn't works, it actually introduces extra level of indirection. And at some point, you have like multiple layers and it's hard to understand what's going on. When functions are consistent, are predictable, like we did here, this is actually like a common idiom. When you have a common type, like when you have a choice type, some type, you have functions to construct these values easily, and you kind of expect what they do. So you don't really need to read their code. You already see what they're doing and understand. So it's expected. All your custom functions, they're not expected. People don't expect your weird functions when you write this thing. So this is basically good enough place to stop here for this part. And we can go a little bit further. So you see, we do all this stuff where we get by integer and then we transform. And so here again, don't see how make message is useful. When it should be called make message too. Yeah, make message is fine. It's maybe like my old functional habits, where like it's like standard convention to call mk's make. The function languages supports like terse notation and whatever. Make messages kind of reduces this like log message thingy and extra reduces like extra cost, and it's like standard thing. Reduces noise a little bit. You can say that, yeah, this like make message can be log message. True. I guess in some sense it allows you to kind of keep it a little bit of abstract of this name. Let's say if you want to rename this name, let's say you want to change the name of this type, so you will change it only here, but you won't change it in every use case. And it kind of allows you to decouple this implementation details. Types are renaming. It's kind of like designing for evolution. You're not sure if it should be called like log message, or maybe full log message, or maybe like partial log message with error, whatever you decide to rename it, and then will be like all of these things. Not really big idea. It's more like when you reduce this noise, you can kind of see patterns. Sometimes it doesn't work. Yeah. People are having some fun in the chat. Yeah, sometimes refactoring doesn't work, but hopefully it will simplify your theme of things. So let's see, what else do we get here? So here we do get integer and transform, and we can create function which like called get int and transform or whatever, like get timestamp, for example, and it we pass it like a number and lambda. But this basically won't save you much, and there is another cost to introducing helper functions, because they make the code harder to read. So in this particular case, we don't obviously see more potential factorization opportunities that will actually make the code better. So you can try to abstract these two functions, but then you will kind of solve this like potential thing. Maybe it's a good thing to abstract this part. But again, when you do like the structural abstraction, it makes things harder to do. So not convinced. Maybe it will be better. maybe you can try to play with this code on your own and see how it works. It's actually better. I'll try to experiment with this. I'll try to see any other opportunities, and maybe on the next stream we can do more of this stuff. But for now, I think we can stop here. We spent a lot of time on this problem, and yeah, we didn't even solve the first problem and want to parse like a string of log messages and do this stuff. But anyway, I think just to keep people's sanity and not have our brains cooked by functional programming C++ too much, we can kind of pause on this. And yeah, if you have any questions, we can stay a bit for discuss. If you have any suggestions for the stream, also let me know. For simple parsing, one could use selective applicative functors. This is a great idea. I'm not sure how ergonomic they will be in C++. I need to play with applicative functors. So actually, one of these homeworks in this lecture, this like course, it's about applicative functors and parser combinators. So we will actually try to implement proper parser combinators in C++, and parser combinators usually what helps to write this parsing easier. So if you actually have like proper parsing combinators library, the stuff that we did will be much easier. So it's more like it's really ad hoc. What we did is like we just throw a bunch of lambdas and did this like lots of manual stuff. Sparse combinators is really easy. So maybe once we have this like applicative library, we can go back, revisit how would we do parsing and all of this stuff. I'm gonna do it in Zig and show you how beautiful it is. Yeah, someone mentioned OCaml and Zig. Language beauty is really nice and great. I really love OCaml. OCaml is nice. Haskell can really serve and elegant. Yeah, so feel free to do it. You can do stream as well. You can see people dig into Zig. Yeah, I did some interesting stuff with validation selective in Haskell. It was good fun stuff. Anyway, I think that's all for today. So there is much more in this exercises, specifically in this one. So we next time we need to parse all the like lines. Maybe I will see any other refactoring opportunities in the meanwhile. And then what we're going to look into actual like recursive data types. There's like will be binary tree, and we will be like inserting into the binary search tree all of this stuff. It's like will be lots of fun, and we'll figure out how to work with recursive types. But yeah, this should be all for now, and really thank you all for joining and commenting and having a lot of fun. Feel free to send me feedback anywhere in the chat, on Twitter, X, on email. You can find me anywhere basically. And yeah, thank you for your time. Cheers.